Welcome to Chem 2. This is Unit 0, Review of Chemistry 1, Video 5, Balancing Chemical Equations. So in Chem 2, Balancing Chemical Equations, that's going to be something that we use a lot. We will look at double replacement reactions a little bit more in depth later, but for the most part, we really don't have to predict products all that much. So there is really no definite way to balance equations other than just do them. We know that we have to have the same number of each atom on each side because of the law of conservation of mass. But there is an order that you can use to balance equations. Usually I start with metals first, and then I do nonmetals. And if the polyatomic ions are the same on both sides, you can maybe keep them together. And then there are two nonmetals that we're always going to save for last, hydrogen and oxygen. And that is because they are common to a lot of compounds, and it's easier if we balance the non-hydrogen oxygens first. So if we look at the first example, we have C4H10 plus O2 yields CO2 and water. This is a combustion reaction for those of you that remember types of reaction. So with this one, we would go through this, and I highly recommend that you use a pencil for balancing chemical equations because if you have to erase, it makes it a lot easier than crossing things out. So if we look, we don't have any metals. Nonmetals, so C, H, and O are all nonmetals, but we're going to save the H and O for last. So if I balance my C's first, I have 4 C's on this side. The only thing that I can do are put coefficients on these lines. So if I need 4 C's on this side, I have to put a 4 in front of here. Now I can balance my H's. I have 10 H's on this side. I have 2 here. So what number times 2 is going to give us 10? Well, that's 5. Now, this side looks done. So I'm going to count my O's on this side. 4 times 2 is 8, plus 5 times 1. 5 plus 8 is 13. I cannot put a whole number here that multiplied by 2, it's going to give me 13. So when this occurs, double everything that you have done so far. So we haven't done this one, but we've done this one. There's an understood 1 to be there. So it's going to become a 2. This 4 is going to become 8. And this 5 is going to become a 10. Now we have 16 plus 10, which is 26 O's. What number times 2 is 26? Well, that is 13. So there is our balanced equation. C4H10 has a name. It's called butane. It's what's in those lighters that you might light a candle or a barbecue grill with. If we look at our second equation, our second example, we have lead-2 nitrate plus potassium iodide yields lead-2 iodide plus potassium nitrate. This is a double replacement reaction. So we have metals, we have a polyatomic ion that appears the same on both sides, NO3, and we have I, which is a nonmetal. So if we look at this, our PBs are balanced as written. Our Ks are balanced as written. But since NO3 appears as a polyatomic on each side, we can treat it like a unit. We have 2 NO3s on this side, so if I put a 2 in front of here, that gives me 2 NO3 groups on this side. Our I's are not balanced. We have 1 I on this side and 2 I's on this side, so we need to put a 2 in front of the Ki. And now we see that our Ks, our potassiums, are balanced on both sides by doing that. And as always, you can always double check these. So I have 1 PB on each side, 2 Ks, 2 Is, and 2 NO3s. You can go ahead and work on the example problems.